Welcome to the Go-Kart Carburetor Diagnostics course. First thing that needs to be understood is what is a carburetor, how does it work, and how can you affect its function and troubleshoot it so that you don't have so many problems. The largest part of our bills comes in fixing carburetors. Well, the first thing that we need to understand about a carburetor is that it operates on the principle of vacuum, and the principle is this: that when air goes past a bump like this, or a hill even, for example, there is a vacuum. There's a sudden increase of air speed. What happens is that the air must increase in speed in this general area right here, and as it goes over the bump, the air must spread apart, and spreading apart it creates a vacuum. In a carburetor, we take advantage of that vacuum. Okay, because there's a vacuum going on in this general area right here, the carburetor actually is designed to be a mini hill of sorts, but because you have to machine it, it's actually a hill that has a bump like that. So what happens is air comes through here, through the carburetor. It doesn't go through the wall, but it goes through it like this, and when it gets in the general area, there's air right here that's getting crammed, and then it wants to go around and increase in speed. Same here. So you get a high speed, the air speeds up in this general area, and a vacuum emits. So what a carburetor does is it has a little tube in this general area that sits in a bowl of liquid. The outside air pressure is atmospheric out here, and it's being rammed through. But as it comes into this area, it gets the pressure drops. So the atmospheric air actually pushes down on this fuel, or this liquid, pushes it up into the tube and out the hole, and then it mixes with the air. That's the basic principle of carburation. Okay, so last time we learned that the atmospheric air out here actually presses down on this fuel. Say there's a level of fuel in here, and it presses down on it and pushes it up through this tube. If I can draw in the lines, can't do it today. And it actually meters gas through this little hole, and then it sucks it into the engine and causes combustion, and we have a baby on the set. Okay, last time we talked about how the air comes through a port, and when it comes across a bump like this, that actually makes a vacuum. And what happens is, in a carburetor, you actually have liquid in here, and because there's a vacuum means that the pressure on the outside of something is greater than the pressure on the inside. And really what that translates into is that this pressure out here can get in here. It's the atmospheric pressure, and it pushes down because now this pressure in here is lower. It actually shoves down on the fuel and shoves it up through the tube like this, and then it comes out into the air as a spray, psh, 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 and mixes with the fuel and goes into the engine and causes explosive power, boom. That's what we use to make an engine run. This is the basic principle for engine operation. Okay, last time we talked about the basic carburetor operation. One thing that we've added to the mix, though, is how do you keep the fuel in the engine from just running full throttle? Full throttle merely means that there's a valve in there which is either open or closed. This is a throttle. That's what that is. And the valve, all it does is it meters how much air goes. If it's closed, you can see the air has to try to go around the corner and get in there, and it gets blocked by this plate right here. Now if the valve is open, do this little undo marker here. If the valve is open, then you can see that the air flows freely past here and into the engine. The throttle is merely a metering of air. It adjusts how much air goes in. It regulates how much air goes into the engine. As it regulates how much air goes in the engine, obviously it regulates how much fuel air goes into the engine. That's all throttle is. On a carburetor, there is actually another valve that's in the front of the carburetor. may be asking, what is that valve for? That valve is called a choke. C-O-K, whatever. Okay. And the reason why it's called a choke is it actually cuts off the air going to the carburetor. And if you look at what actually is happening, if the air coming in is being stopped, then where can it go only? Well, it has to go down into the bowl and up through the fuel. So you're going to get more fuel into the engine. You may be asking why. Well, when the engine is cold, it needs to heat up to the optimum temperature quickly. So if you add a lot of fuel to a fire, what happens? It gets hot fast. So a choke adds more fuel to the fire, if you will, very quickly. And so what it does is it cuts off the air supply coming into the engine, reverts it towards the gas part, and allows more gas to come in. And you'll notice that when you try to start an engine, you can't run it on choke very long. This particular the choke, understanding how it works, is very helpful in diagnosing whether or not a carburetor is broken or what's going on inside there. Now there are other parts of a carburetor, and we'll finish up with these. When you try to get an engine to go quickly, to accelerate quickly, you suddenly open the throttle, say, then there actually isn't enough pressure drop here to meter enough fuel into the engine. So there's a secondary port that's typically put about right here. It has a little metering jet of its own, and it sucks fuel as well into the engine, and it helps give the additional kick that's needed when you turn on the throttle, full throttle. Also, it's called the idler screw. When the engine is fully shut down, you're not going to get enough fuel going in here, so it typically is mounted right behind the throttle plate and just meters in fuel just so the engine will run. This is a video on bowl and float fuel regulation into a bowl style carburetor. In the carburetor introductory course, we showed you how, when air goes in, fuel comes through the tube, up and so on into the engine. Well, the fuel is actually stored in this general area in a bowl. That's what it's called, a B-O-U-L. And the bowl has a float in it. That's this float. And the float is designed to regulate how much fuel actually sits in this reservoir. And all that reservoir is designed to give the engine its needed amount of fuel, so that when you stop on the gas, you don't run out of fuel. And one of the keys to understanding whether or not a carburetor is broken or not is when you step on the gas, does it suddenly quit? If it suddenly quits, then it should be telling you something that there isn't enough fuel in this reservoir. Now the way that this reservoir system works is that the float here, nice little float, actually is a special regulator. And when it moves up in the air, because it floats literally on the gas, when it moves up, it actually pushes this little valve up, and it stops the fuel from coming in. When the fuel level gets low, this float drops down and allows fuel to come in to the bowl, and then it comes to a certain level, which is about right here, and then it closes, and it's constantly cycling on and off, on and off. Now, on an engine, one of the things that can occur is that this float can either be adjusted wrong, this tab can be bent too high and cause this needle valve here to prematurely shut, and you won't have enough fuel in the float area.